If we consider the original ideal four-process refrigeration cycle of this picture, with a non-condensing gaseous working fluid, four-process with non-condensing working fluid. Then the work output during the isentropic expansion process is not negligibly small. The work output isentropic expansion, this part is not negligible. Negligibly small, as was the case with the condensing working fluid. Therefore, we retain that turbine is the for steady-state process ideal air standard refrigeration cycle shown in the picture. This cycle is seen to the reverse Brighton cycle, and it is used in practice in the liquefaction of air. And other gases, and also in certain special air and other gases. And also certain special situations that require refrigeration, such as aircraft cooling system. Aircraft cooling system. After compression from state 1 to state 2, state 1 to state 2 in a compressor, the air is cooled as heat is transferred to the surrounding and temperature T0, this part, temperature T0. The air is then expansion in the process 3 to 4 with the expander to the pressure entering the compressor, and the temperature drops to T4 in the expander. T4. We have in TS diagram two isentropic process. Heat may be transferred to the air until temperature TL is reached. The work for this cycle is represented by the area of the 1, 2, 3, 4A, and the refrigeration effect is represented by the area refrigeration effect. The coefficient of performance is the ratio of these areas. So we have COP QL W compressor minus W expander H1 H4 H2 minus H1 H4. Let me provide the picture again. We can write these relations. QL on W net, QL on WE, H1 minus H4, H2 minus H1, H3 minus H4, and equals to CP using a constant specific heat to evaluate the differences in enthalpies and writing the power relation for the two isentropic processes accurate in these parts. We can write this relation. Beta Here we use T3 on T2, T4 on T1, and RP equals to P2 on P1. And we have a result similar to that of the other cycle. The refrigeration cycle is a Brayton cycle with the flow in the reverse direction, giving the same relations between the properties. In practice, this cycle has been used to cool aircraft in an open cycle. A simplified form is shown in the next picture. The aircraft cooling system. Cycle. Upon leaving the expander, the cool air is blown directly into the cabin through providing cooling effect where needed. When counterflow heat exchangers are incorporated, very low temperature can be obtained. This essentially the cycle used in low pressure air liquefaction plants and in other liquefaction devices such as cooling helium liquefaction plants for air and other cooling helium liquefaction. The ideal cycle is as shown in the picture here. Because the expander operates at a very low temperature, the designer is faced with unique problem in providing lubrication and choosing material.